is the FRC Roundtable, coming to you all the way from Minnesota. Your host team 2052 Nightcrawler presents this weekly FRC gathering where FIRST Robotics competition teams take cooperation off the field. Share your knowledge, give and get advice, solve a challenge, or celebrate what makes your team special. 3, 2, 1, go!
Yeah, and I can also message Nick out from the Mythic, and he's been all right at a few events.
Awesome. All right. Well, I have started the recording, and I will, Riley, the floor is yours. It's your topic tonight in case, electrical. All right. So we're talking about electrical. Riley, take it away.
All right. So for an introduction, I'm Riley Lamont. I'm an engineering captain on Team 2502, Talon Robotics. I'm here to listen. I'm not here to talk to you about how to do electrical. As you can see by the picture of this robot, we're not particularly good at it. I think this past MRI, we took, electrical failures in all but 2 of our matches. So that's really what prompted me doing this, is to hear from other people on how they do electrical so that it doesn't fail every match. And then before we get into this, I'd like to go around and have everyone share what their team's philosophy is on what your goal is when doing electrical. So, that's John Stratus. I'm going to repeat that for our new join. We're going to start with what everyone's team's goals are when doing electrical. We're still getting our goals for the season figured out, but I think the most likely one we're going to settle on is reliability, not breaking, ideally, ever. So if someone wants to join in with what their team knows.
I'll start, but I'm probably not the best example. This year, we tackled some swerve drive, and that was kind of the priority. And electrical fell by the wayside, so it kind of just fits down in the bottom there and it sloshes around a little bit, which does cause problems. And it did this weekend at our conference championship event. We had some issues, but we went through whole events where it was tight enough where it didn't. 2 years ago, we had a really good plan and we drew it all out on paper and kind of on a template. And we had very little to no problems that year. But so it's all in the pre-planning. Usually you just kind of want to try to get things working. And once they work, you kind of hesitate to change it because it's working. And then you just go with that to the regional. And once it sees the abuse of a real competition, that's when it starts to fail. So I'm here to learn too, but pre-planning and having that part of the procedure is super important.
Yeah, I would second that. So 3926 has historically been mediocre about keeping our wiring not being a rat's nest. Generally not the greatest about it, but not like terrible. And this year, because I think it was our smallest robot in our team's history, and we didn't really have much on-robot real estate, we said one of the requirements that we wanted to do to make sure that we could pull it off is that we'd have to CAD out all of our electronics before we placed it. So we knew where all the electronics were going to go, and we made sure we had space for that. And I think that made it a lot neater for us. In the way that we were able to plan out things. The other thing we did was we put all of our items in our CAN loop in sequential CAN order. So the first item was CAN ID 1 all the way to, I think it was like 15 or 16. And that way, when something did get lost on the CAN loop, we were able to pretty quickly identify it. I don't think we ever had something happen in competition with any of the wiring. It was all fairly robust in the way that it ended up working out, which was nice. We had, I think that.
All right, yeah, we'll get more into planning later. My goal here is just try to see if we're all on the same page. Like, for example, if there's a team that's goal when doing electrical is hide all of the wires and have a really pretty robot, that is going to reflect in different policies and different strategies and different everything. And I wanted to get that all out of the way first. But it seems that we're mostly on the same page if we want our electrical to function and be reliable.
Yeah, and I know a goal for Nomythic here, along with that, because we also cat out electronics and stuff, but we also make sure that replaceability is a big thing. Because we do a belly pan, which has all of our main electronics just laid out right there. And we make sure that that is accessible and that all components are easily accessible. And then if there's like motor controllers and stuff, we make sure that those are all accessible on the subsystems. And that if need be, we could swap a subsystem or something and the electronics wouldn't be too hard. So replaceability is a big thing.
Yeah, I feel like Nightcrawler, well, like Scott said, Nightcrawler has been kind of like throwing the electro to the side, but I think recently we've done a better job at focusing on accessibility and countering electronics and actually planning them with the robot instead of just like having it be a side thought. So we've done a new thing, or yeah, fairly recently with our like last two robots that we put all of our electronics kind of like centrally on the robot. Like we have a belly pan, and then we put all of our electronics basically on the base and try to minimize the amount of electronics we have high up. So if anything does get hit, hopefully it wouldn't be a wire. Yeah, we minimize the amount of like encoders that are high up and whatnot.
So a lot of reliability and also accessibility.
Yeah.
All right.
Riley, do you want to talk about strategies now, or are you focusing on goals?
Just goals for now.
Okay.
We're getting the strategies.
All right.
So, and then the other thing, so to keep us all on the same page, is designing around electrical. So I'm talking about high level. So like what mechanisms you put on your robot, what you're deciding to prototype at kickoff, that kind of thing. And this is to account for the disparities between these two robots. Nightcrawler, you've got one moving motor, right? We have 4, and all of them are on the elevator. Some of them have multiple degrees of freedom. Does anybody make it a point to keep their robot simple in that particular way, or something along those lines?
I will expand a little bit on what you just said about we have one moving motor. Nightcrawler, ever since I've been involved with the team, it's been 8 years now, has always had a philosophy of don't use a motor where a piston would work. Now, that may or may not have been the right choice for us last year with this robot that you've got in the photo here, because our intake was a clunk clunk. It was pretty aggressive. It wasn't easy to control that pressure and get that dialed in right. But it did have the advantage of very, very few electronics up in the air. So, yeah, to answer your question, does anyone design around it? That is kind of a core design feature that we use, is that if you can use a piston, use a piston, because it's easier to code and easier to troubleshoot. But we may overuse that strategy.
On Nightcrawler and I guess other teams, so this was 3926's first year using pneumatics, and we struggled a bit with it. And we considered it like almost a part of the wiring for the robot, where we were almost wiring, the air down to our solenoids and piston. I guess, solenoids and pistons rather than, electricity. And we struggled when we had our pistons on moving components, and that was partly because we had the 2 pistons that were attached to each other back to back, but that caused a lot of disconnection. So are there strategies similar to the strategies you use when you're having wires that are moving that also work for preventing those disconnections with pneumatics? That might be a whole nother day. of question.
I'm gonna let, if you want, I want Kevin to respond to that before I give any advice that I have, because Kevin's our build captain and I want him to go first.
We'll also get into strategies for reliability later.
Oh,
Eric?
we can hold it if we want.
Mhm.
What do you want to do, Riley?
I'd rather we hold it for when we get around to this slide.
Well, I wanted to talk about the choice of, for the first time that I know, we decided for last year to take the pneumatics off the robot. It was a team choice, and I don't know if it was helpful or not, but it just happened to be a decision by the team, a change in strategy. So just discussing pneumatics. If we go back or not, I don't know, but that was just a strategy for last year.
Yeah, we did that after our pneumatics was breaking constantly. After reflecting on that, it seems that it was mostly a us issue, not a pneumatics issue, considering how often our electrical breaks. But if anyone else could elaborate on the decision to use pneumatics.
Yeah, I can talk for Pneumatic here because we were in a similar boat there where we started with pneumatics, but then halfway through took them off. That was partly because we added a subsystem, took a subsystem off, did some shuffling around there, but we had a similar thing there. And one of the big things behind the reasoning to take the pneumatics off was because we didn't really have space for the air tanks, or a good spot there. And so one of the things that I can think about with pneumatics is that the robot really needs to be designed for pneumatics, and because it's a lot of components. So we also took pneumatics off though.
So pay a lot of attention to the decision around using pneumatics at kickoff, because this is my takeaway, by the way, is whether we. Sorry, I'm going to start over. My takeaway from all that would be that everyone should be paying attention to the decision on whether you will use pneumatics or not when you're at kickoff, because it is a lot of work, but it, as Nightcrawler seems to have it, it can be a lot of benefit.
Mm-hmm. Well, Patriots were very successful with pneumatics this year. So it was just part of their design, I guess.
And I think for all intents and purposes, the pneumatics question can partially be boiled down to almost a trade-off between mechanical complexity and wiring complexity, I guess, compared to coding complexity, because I think there is a real gain to be had when you only have to, code piston go out, piston go in. And that makes, everything once the coders get the robot go a lot faster, because there's no PID tuning or anything like that.
Yeah, I think the use of pneumatics is really just like a balance of how frequently you're gonna use them and like how much air is it gonna take to move that thing, right? So it's like for 2022, we had a lot of success with our pneumatics because it was just pushing out our intake, which is small thing that doesn't require a lot of force to move, and we don't use it as frequently, or well, we use it a lot, but like it's not like every single second. But I think one of the reasons why we struggled with pneumatics more this year was because we had to use our pistons for everything we did because it was our intake and scoring mechanism. It was also the force it took to pull out the piston pull out the intake, just because you're trying to have something that goes up and down, or like not up and down, but like a linear like action to a rotational action. So it just took a lot more force to push that intake out than it did in 2022. So yeah, I think it's a lot about balancing how much you use it and how much force it takes to move it.
All right.
And out of curiosity, how many air tanks did y'all have?
We had one originally, but then after some testing, we realized we have to add another one. So we have two in total.
We have one total. we had the similar thing where we had to use it for both our intaking and scoring. We used it for gear shifting last year, and I think we barely were able to get away with only having one. I think if we were starting to do more than 8 cycles a match, it would have required us to do 2 based on the calculations we made. Don't quote me on that, but I know that the math existed somewhere and someone did it, and we calculated that we only needed 1.
Well, it's interesting that you discussed gear shifting, and that was one of the reasons that we were able to get away from pneumatics. Was when we went to the swerve drive, we no longer needed the pneumatics for our tank drive gear shift. So that gave them, I know I talked with Patriots, they used 3 tanks. They said that would last them an entire game, but it didn't work during practice. But definitely would work there 2.5 minutes. It was worked well for them.
Yeah, and they were almost all pneumatics.
The bit of trivia, funny story. For Recycled Rush, Nightcrawler had, I believe, 15 tanks on their robot. And there's a funny story of they went to weigh in and they were 1 ounce over 2 ounces overweight when they weighed in. So they let all the air out of their tanks and then they passed for weight.
All right. One other thing that's been floating, this is just because it's been floating around in my mind for a bit. Does anyone have experience with linear actuators, like the off-the-shelf ones that we're allowed to use as a non-pneumatic replacement for pneumatics?
We've never used one in a robot, and I'm not sure about the off-the-shelf one, but we use it for our t-shirt cannon. They're really slow, but it works. So
The one that we have is slow. I mean, they're probably faster ones. They're not going to be as fast as a piston, though.
No, they're not as fast as a piston. And the ones that we've bought, like the Dart ones, are hard to work with, kind of. I know Ryan Swanson with 6045 for their arm. That was a linear actuator, a homemade one actually, and it worked pretty good throughout the season. I mean, they had a pretty good machine this year, so it is an option.
I think the one thing that you have to think about with the linear actuators is that you have to put them so close to your pivot to get the speed you want out of them that it's a lot more pressure on the arm. And they broke in the finals at state. I think that was their linear actuator that broke in the final match at state, and then their arm was down. Of course, it made it through the entire season before it broke, but I think that is something to think about, is in order to get the speed you need, and with whatever the stroke is you have, because your stroke might be pretty short as well. You have to put it really close to your pivot. So you have to know how much force, how much torque you're going to have on that to move that arm.
although I think there is an advantage with linear actuators because you could go in between, like your final distance and your starting point. So if you wanted the strength of a piston, or like not the strength, but if you wanted something like a piston, without having to use a motor, I think linear actuators might be a good investment.
You do get into sketch controls at that point, because most of those are rushed motors without encoders.
True.
Just be careful of not having any extra. I think it was the torsional force that we had back in Power Up. We were using for a climbing mechanism, and we totally ripped them apart. Kedrick might be able to remember a little more of what exactly we did, but they're not a definite replacement for pneumatics.
All right. Cool.
And
So now-
basically, the pneumatics are if you have a single position you want to go to. If you go to a linear screw, now you have infinite positions that you can go to.
Well, you're going between hard stops, but yeah.
It's basically a choice of when you go to a cylinder is a single position.
All right. Moving on to routing. Got some nice pictures going on here. So, going to start off with where do you put your wires? Are you putting them inside your tubes? Are they free floating? How well mounted? How well do you mount them? And how well does that all work out for you?
We used the wire mesh stuff in the upper right this year because we were kind of like 2502 there. We had motors on a elevator, on a wrist, on a intake that flipped out. So we had motors all over that moved and needed to be able to move. So we used the sleeve. That worked nice as far as managing all of them and keeping them all together, and then just zip tying them and making sure you got some strain relief in there. And then we used the drag cable for our up and down on our elevator on the upper left. We just borrowed that off of one of the CNCs in the shop. Well, I'll put it back soon, I promise. But yeah, I mean, you need something, otherwise they're going to get caught on stuff for sure. My experience with the ribbed plastic split stuff is not great. I don't like it. But I do like the little tie down things, which we don't use. There's some other 3D printed stuff that we've used, but yeah, definitely need some kind of thing to keep them all together.
Last year, we, instead of using something like the top left, we kind of made our own kind of energy chain with a sheet of plastic. And that was for a few reasons. Of course, like first is accessibility. You can't really, if something for whatever reason gets broken within that chain, or on our like intake, if the wire gets disconnected, which I think did happen, you would have to unroute all of that or disconnect it somewhere. Yeah, it's just a pain. So we just put a plastic sheet and then put our wires kind of like on the inside of it and had that kind of got our wires up. And then we also had pneumatics, so you probably can't fit pneumatics within that, or it had to be really big. So yeah, and that fits within our like kind of philosophy of like putting wires that are in places that are accessible, but also kind of like hidden away so it doesn't get hit. So we want to put all of our wires on the inside of the robot, and then in a place where you can access them.
I'll see if I can find a decent picture of that plastic strip. It's really hard to explain, but it basically acts like a drag chain, but it's sort of open on one end, so you can just cut the zip ties, route a new wire in there, and zip tie everything back
So
up.
this is just like a thin sheet of polycarb.
It's a flex. Yeah, I don't know if it was a polycarb or if it was something else, but it's basically a flexible, very thin, less than 16th, I suppose. But we cut it maybe 6 inches wide, and then we drilled holes so that we could zip tie through. And so we just routed our wires and our pneumatics on that thing, and it basically just rolled up like an energy chain would roll up, but it was a clear piece of plastic. It was a little bit wider too, so it made it less likely that somebody would be able to like snag it, because it was sort of actually it was underneath of our back protective cover, so nobody could I'll see if I can find a photo. It's
Is
hard to explain.
anybody using the energy chain?
We used energy chain last year on our on the 720 degree turret for the wiring. It was, I think, well, that turret was a pain for a lot of reasons. But the energy chain was a part of it because it was really, at that amount of use, it was really hard to guide to make sure it was looping back on itself at the right moments. So we kept having segments of the chain snap, and then we'd have to either replace them. We generally just always have to replace them in between all of our matches. And then also, if a wire in there broke, that means we'd have to unroute the entire thing and reroute it. And that happened twice over the season. One time it was our cable going up to our limelight. So what we ended up doing was, because we couldn't do it in time for our matches, our second regional, we ended up only using the turret for, I think, like 90 degrees of its initial range, and just having the cable not be part of the energy chain route. And then in the postseason, we had a CAN cable failure, and that was just in there, and we had to take it all the way out through the entire line and then reroute it, and it took a solid hour just to access that one thing, and it was really painful.
Thanks.
When people are referring to electrical breaking inside these, are you referring to connectors coming out, or are you actually snapping copper?
I think it was like a mix of like they would come off, but then also like the flaps at the top would just snap off a lot.
Nightcrawler used energy chain. I think the last robot we used it on was 2020 for our infinite recharge robot, where we had that it would go up and grab the pipe that you'd balance on, and then we had a motor up there that would drive back and forth to balance the pipe. And so we had to have an energy chain that would run up that retractable arm in order to run that motor that would drive back and forth on the pipe. So we have used energy chain in the past, but I think we also had a problem that year with it continually kind of falling apart. And so I suspect that was the reason why we didn't put it on this year's robot.
I'm just going to point out the image in the bottom right for anyone that may or may not recognize it. These are new to us. We have not used them for the past at least 3 years, definitely as long as I've seen in robots. Although apparently we've had them sitting in the room for at least that long. And so they're very nice. They just stick down onto something and you can put a zip tie down around. Very, very nice for routing wires.
Yeah, I agree. We used them for 2022 robot. I think it was for the radio and something else. It was for like items outside of our main belly pan. Yeah, they're really, really nice. I wish we could have used them more, but
Yeah, they're super nice. We used them all over the place on our robot this year, and then on our swerve base this year. They've been really convenient.
Yeah, I agree with what's being said. Yeah, and we do use them on the belly pan. And we actually use the zip tie like stickers or stick things a lot more than the like cable or the like drivetrain or the wire cables. We only really use those if we have some sort of rotational mechanism. And apart from that, it's pretty much always those zip tie stickers.
I saw one team at MRI used pneumatic hose that was the spiral hose. And I saw that they had routed their wire with that and zip tied it to the hose so that as their elevator went up, the coil, it's basically the same yellow hose. I think it was the yellow hose that when you buy a Home Depot or Menards, you buy an air compressor and you get that coiled yellow hose that comes with your air compressor that you buy. I think that's what it was. And then they had wired their wire on that coil as well and just zip tied it every few inches. And then as it went up, the coil expanded, and as it went down, and that they use that for both routing their wire and their hose.
And one more thing I want to point out with routing that I haven't really heard mentioned here, but one thing that Nomatic has been doing and has had great success with was if you are having a bunch of cables that are going up some long distance, is putting some sort of tape or some sort of marker at each end, because then you can see the like purple wire or like the purple colored wire is failing, and you don't have to go through each individual wire. So that we've had a lot of success with.
Yeah, I mean, and we don't do it very well, but like, your motors 1, 2, 3 on your CAN bus, label your motors, label the wires that are going into your motors, or not on your CAN bus, on your PDP, and then have that all correspond so you can see which one's not working, so you don't have to trace it all back. And again, prior planning, but that makes it easy.
We've used like surface mount cable raceway before too. So like the stuff that they inside schools, they'll run like low voltage through it. that mounts to the wall. We've used that as like a wire raceway before, and it protects the wires.
Yeah, I think Kirk posted that in the chat.
All right, moving on. I know a lot of people have varying levels of success with the reliability of the various things we've got. So, talking first of all, what do you use and how do you make it reliable? So, with speaking to motors, we've got motors with integrated controllers, got Neos and Neo 550s, and we've got brushed motors. If anyone's got any comments on what they've found with reliability for these and for any of those, and how any ways they've solved these problems to share, that'd be great to start now.
Well, you sort of alluded to it in the start when you talked about Nightcrawler has one motor. This last year we did not run the can above our chassis, and so that really restricts you in terms of what motor we could use on our intake. Kevin, what did we use for? Was that a mini sim or was it a bag motor?
For our intake, we used a 775. Yeah.
So we used the 775 with a Talon SRX motor controller, and we kept the motor controller down in the belly pan. So all we had to do was route a positive and negative wire up to that motor. We didn't need an encoder on it at all. So that really, to your point earlier about reliability, if anybody was going to snag our robot, they were at worst going to pull out a power wire out of our intake. They weren't going to blow out our entire can and screw up our sort modules or air compressor or anything. So that was a conscious decision not to put anything up on the intake that would require a can wire up there.
We use the Falcon 500 stuff, and they're good until the wires break off right by the motor, because then they're garbage. And we had one just last weekend. Again, one of our swerve drive, the steer motors came loose, and it kept spinning when it was not really attached to anything, and it wraps those wires up, and that's unfortunate. So I'm excited about the Kraken ones because they are replaceable, it sounds like.
That's the Neos and the Neo Vortexes and Spark Flexes.
I think the Kraken is too. I believe. I know they have Andersons that plug into it, but anyway, that's kind of the disadvantage of those. And then one for like Scott's situation, to separate CAN bus, they have like the Canivore that you can isolate the drivetrain as opposed to other mechanisms. So if you lose one of those CAN bus wires, I think the rest of them still work if you have like a Canivore type of system. But that might just be CTRE compatible. I'm not sure.
Yeah.
Neo Vortexes or Spark Flexes, I think they said that they're CAN FD compatible, but it depends on if CTRE wants to let them work with the CTRE ecosystem. So we'll see if Neo Vortexes will be able to work with them.
And regarding the Canivore, Numithic has used the Canivore this past year and has had great success with that. Because the motors that we use Falcon 500s for our drivetrain, which has been swerved this past year. And then for our other systems, we use Neos. So that's either the big Neos or the Neo 550s. Those work great, except for the Spark Maxes can sometimes be a bit goofy with connections, but using that Canivore has been really helpful, because there's been at least one match I can think of that one of our Sparks stopped working, but we could still drive with the Canivore and the drivetrain, which was really nice. And I guess along with that, sort of an interesting perspective here that's different from Nightcrawler is that we always put our Spark Maxes as the motor controllers for the Neos. We always put those with the subsystem. And so we do run the CAN all the way up, which has mostly worked out. As I said, there have been a few times that we've had spark issues, but it works mostly okay.
We purchased a Canivore, but it made us really nervous to put your most important mechanism, being your drivetrain, on a USB plug. That made us very nervous, and so we tried to work through our CAN congestion issues, and we did actually get to the point where we felt more comfortable with our CAN traffic, to try to avoid putting our drivetrain on the USB plug-in. It's too bad it's not the other way around. If we could put just our drivetrain on the primary CAN and put everything else on the Canivore, I think we would 100% do that. I don't know. It's just my paranoia with how bad USB cables are and connections are, and taking a contact and taking a hit makes me super nervous. But I know that other teams have done it and they've never had an issue. I don't know. I guess I'm a pessimist.
Yeah, 3926 hasn't used a Canivore because, at least for the past year, we've been an exclusively Rev motor team, and it looks like that will be the same this year, because we're a little hesitant to get Krakens in their first year, just because we don't know the reliability of them, and then also not necessarily knowing any issues that might need to be worked out with them. And also, we're just like pretty heavily integrated in Rev's ecosystem, so it would be costly for us. So that has caused us to really need to always be, I guess, focusing on our CAN bus usage, which hasn't been terrible for us. Although I presume it, potentially could get worse on a full robot. We'll have to start finagling some of the values. And I'm really excited for the flexibility that the new Rev motors have, if our team decides to buy them, just because of being able to choose whether or not you want to mount the controller with the motor and have it be more tightly integrated, or have the choice to keep the controller separate from it if you, for example, don't want to run CAN wires up really tall, versus last year when we had a Falcon on our shooter, we had to run those CAN wires all the way up, and then when they broke, as I was saying, it was a mess.
We run our swerve drive totally on the Canivore. I'd have to ask Andy, I know he's listening in, what problems we ran into. I'm not sure if there was encoder problems or something that happened.
We've only had power issues with our CAN coders. I don't think we've ever had an issue with our Canivore specifically.
Yeah, that actually would fit into this slide pretty well. So when we talk about sensors, our CAN coders, we were dealing with this issue throughout the season and could never figure it out. We eventually got it figured out like 2 weeks ago. Is occasionally during a match, one of our drive motors would just start spinning. So one of our swerve wheels, and that would take us about 50% out of the action for the match. So we eventually figured out that it was that it happened whenever we lost power to a CAN coder. We still don't know why we were losing power to these CAN coders. It was a different one every time. The connections all seemed good. Anybody have any sort of experience with powering those encoders?
In your code, were you using the CAN coders past initialization?
We were. I disabled that 2 weeks ago, and that's what fixed the problem.
Okay. Yeah, because I know 3926, we only use them right when the robot turns on. We use it to set the where the swerve wheels are, and then for CAN we turn it to, like, I think it reports like only 1 frame a second, or yeah, something like that. So it has very low CAN utilization after boot up.
We were pretty vocal about it, so if anyone was doing was paying attention to anything we were saying during Rapid React here, we had a dead wheel issue. It was a really prominent issue. We posted about it on Chief Delphi, and some teams would say we've never seen that, and other teams would say, yeah, we see that every time we turn off the robot and turn it back on again as well. We never, and that was with the MK3s and using canifiers or the can coders. We found our programming captain, Caleb, he found something just last week and posted it in our team Slack about something he found on Chief Delphi, that if you set inverted in the wrong order during initialization, that could cause the problem. And so it would not set the signal properly. We've tried both ways, where we just use the initial value one time and then where we're using it all the time. And of course, if your can coder fails to initialize properly, then that one time you try to use it, you're kind of stuck. But if you're using it all the time, then you've got a lot of can traffic from it. So I don't have good advice there, other than to just say that Nightcrawler has also struggled with can coders in the last couple of years.
Yeah, we also actually had the dead wheel issue when we were starting, and we got to go away eventually. What we eventually figured out the issue was that we were trying to take the reading from the can coders, and it was before all of the can coders were initialized, because we wanted to take the reading right on robot boot, but because it takes up to a couple seconds for the can coders to fully initialize, that meant that sometimes one of the 4 can coders wasn't fully initialized, and then because it didn't get the reading, it didn't know where the wheel was, and it didn't react properly. We were able to solve that just by we delayed when we took the reading, or I think we took the reading, only once the robot became enabled, which seemed to have fixed the issue.
One of the strategies that we tried, and I'm pretty sure we left it in, we didn't take it back out, is to reduce traffic on the can when the robot booted. We would initialize our drivetrain, but we put in a delay and we didn't initialize any other subsystems until like 10 seconds after the drivetrain had been initialized. And so the idea over there is that when all these CAN devices are sort of, you're doing these reporting in and you're creating the motor controller and all that stuff, we're trying to avoid creating all these other motor controller. And for the Rapid React year, I think we had 12 motors on the robot that year. And so we were trying to say, just get the drivetrain set up. Okay, now initialize everything else. I can't. Whatever year we were having these problems, we had a lot of things in our can. So we initialized the drivetrain first, and then we initialized everything else, and on a delay.
All right, and then the other thing on this slide is we've had issues with limit switches in the past where we'd mount them wrong, and we'd mount them somehow wrong. We thought it would be fine, and then break the limit switch and then never replace it, and then programming would yell at us for it. Anybody have good experience using limit switches? What sort of limit switches do you use? Anything related to how you make those work?
We used limit switches this prior year. Scott made a case for it. He could speak more on this, but we noticed that our limit switches were prone to breaking, as you said, right? So Scott decided to make a case that he sent in the chat right now that basically prevents like too much pressure being placed on the limit switch itself and transfer it to like a finger.
Yeah, I actually made this limit switch for 2019 or 2020, and we never used it until this year. And it was me messing around because I was frustrated with something that was breaking on a robot. And so I created this. For anyone who's watching the replay, you don't have access to the chat. But if you go to Thingiverse and you search for FRC limit switch, you can see the switch that our build captain that year posted. And this is just using a 99-cent limit switch from Axeman as a cheapy limit switch. But you don't have to use this. You can make your own. I mean, the idea was that, you just put a little finger on a spring and then you do an offset and then that pushes your limit switch. So the idea was that no matter how far you slam this thing down, you'd never be able to crush your limit switch. Nightcrawler, for the most part, has had a really awful history with limit switches, and because they always break or they always get smashed or they get broken. And so I was messing around back then. I think it was in SolidWorks. Now we use Onshape, but I was trying to come up with something that would work, and we pulled it out of the drawer this year and we used it. So hopefully it'll be hopefully that'll inspire some other students to come up with some better designs than this little thing that I came up with years ago.
Yeah, in my time on 3926, we've had trouble with our limit switches being crushed or not working. Something interesting I was found today was Spectrum from Texas. They posted a video that went through their entire design of their CAD this year. It's like an hour long. A wonderful dive into their robot. But something they talked about was their 4-bar actuated with a motor. And they designed the 4-bar where instead of having a limit switch, there was the hard limit of the two bars colliding with each other when it was fully extended. And I think they were talking about how based on like current limits in the motor, they sensed that, okay, at that point you stop because it's at that point it was pushing into itself and it almost acted as its own version of a limit mechanically.
Yeah, I should phrase this. So I am not a programmer. I am a builder. But I feel like No Mythic has used some sort of current limiting. I don't exactly know where, but I think we've had success with it. Maybe I don't fully know though. But I also know 4 limit switches for just like your Andy Mark limit switch. For those this last year, because we had a double jointed arm. Before that, we just put 2 metal rods so that the little metal finger thing of the limit switch got out. But if the arm went further down, it would just hit those metal rods. And we never broke limit switch this year. And so we just sort of built that cage around them. The bigger issue that we've had was with electrical and just not connecting them up correctly, like doing the soldering incorrectly. Or like last year we used sparks and we had an issue of the board falling out of the little port on the spark. But no limit switch is crushed as far as I know.
I know for us, we've had problems using the micro limit switches in the past, and we've generally moved away from those because they do tend to break, or the little bar on them starts to bend out of shape a little bit, and so then it's not triggering repeatedly. And so we've moved over towards some larger, heavier limit switches that are much more robust. I'm going to paste in the chat. Basically, we've got some from Automation Direct, either with a roller bar that's adjustable, or with a 360-degree spring on the end. And these things, so long as you don't hit the body of the limit switch, they aren't going to break. So the arms on them are very robust and seem to last a lot longer and a lot better.
All right. And while we're here, this is a little bit off topic, but I'm curious. What are everyone's plans for new motors?
No Mythic is getting 4 Krakens for each sort of module. We're very excited about them. We're only doing the drive motors though, and then we're using Falcons for steering.
Yeah, I don't think they even sell the pinions for turn motors on Krakens.
I'm sure they will.
Probably.
We're getting 4 of each, and we'll see how they look and what the design calls for. And the nice thing is, you can even if you buy them this year, you can still use them in future years if you don't use them this year.
Yeah, we're really excited about the Neo Vortexes. It's our first year using Swerve Drive, and the team as a whole doesn't believe that we need to be necessarily like super fast on our Swerve Drive. Right now we're using level 1 gearing. I've been pushing us to purchase level 2 gearing. Although we'll see if that purchase goes through. And generally we kind of want to stick with what we know and what we think is consistent. And at least the Neos for now have been that for us. And then in terms of Vortexes, we're really excited for the applications they can have due to their flexibility. And I'm hoping that we'll pick a few up. And that would be, if we did, that would be pretty cool.
Anybody know the shipment status on the Vortex motors? Are they ready to go? Are they being shipped out right now?
I think pre-orders are going to begin in a week or two. And then their goal is to have shipment for pre-orders and regular orders out by December.
Okay, the Krakens look like if you haven't ordered them yet, you're not getting them until after build season starts at the earliest. And if you already have got them, it's maybe sometime in December.
Nightcrawler hasn't pulled the trigger on any new motors yet. There's been a lot of discussion, but we also bought a pile of Neos last year, and we're planning to pull our Swerve modules off of last year's robot to use on this year's chassis. So I suspect we will order some of the new motors and won't plan to have them in time. And if we get them, maybe we'll use them right away. If not, I don't know. But we have not, to my knowledge, we have not pulled the trigger on buying any motors yet.
Yeah, we're just on the fence about like compatibility with the modules and if they actually provide what they promise.
Yeah, and that's kind of where my team was on the fence about it too. I know in the initial days, I was pretty excited about Krakens, but in the end, our team's consensus was we wanted to hold off on buying them, especially, and I think partially because we had some pretty terrible experiences with our first year Falcons, and obviously West Coast Products not being the same company as Vex and not having the same reliability issues, but West Coast Products having never built a motor in the past worried us a bit, and we were worried that they would be, really expensive if we ended up not using them.
For our part, we went full send on it and returned all of the Neos that we bought and bought a bunch of Krakens. With plans to buy Vortexes if they come out, when they come out.
Do they have since you ordered them already, Bradley, do they have a ship date for you?
I don't believe so. I could check in, but I don't believe so. All right, moving on to mounting. This is probably going to be a short slide. So first of all is for the battery, because we in particular had a not very good time with that this past year. So the above is a screenshot from Citrus's CAD. This seems to be the way to go, if anybody else can elaborate, is just encasing it in a bunch of aluminum and putting a strap over the top. Blow is something that we saw on Nightcrawler's bot 2 years ago and stole. And then our Velcro didn't strap down right, so that didn't work. But anybody have experiences with that?
We typically use the old ones from the kit apart chassis that come out, that Andy Mark sells. They seem pretty solid. Lay it on its side, and well, I guess depending on how you want to do it, but or modify it slightly. But yeah, you gotta keep it from moving around for sure. Strap it down good.
I threw
Personally,
out.
I don't like Velcro that much, just because it tends to come apart and degrade over the course of the season. So we use 1-inch strapping with buckles on it. It's very easy to stitch together so that it's the correct length. It's not going to come apart when you don't want it to, and it's been very secure for us.
I threw out in the chat our Thingiverse. So for anyone on the replays, thingiverse.com/team2052/designs. Our battery mount that we use is out there, but we also our build captain 2018, 2019. He designed a 6 high stack for Talons, which you could adapt to also use for your other motor controllers, assuming that you can mount them all together. Because we didn't have real estate, but we could get 6 motor controllers stacked up, 3 on one side, 3 on the other side, in sort of like a little tower that you could mount. And then he also has a design, which I'm not sure is out there or not, where if your Talon required an encoder, there you can buy a breakout board so that you can use the little 6-inch encoder strip that goes from the Talon to the motor, or to your mag encoder or whatever you're using for an encoder. And then you can use just I think it's a 4-wire, maybe a 6-wire, any 6-wire like phone cable almost, to go wherever you want. And so he even has a spot where you can mount 6 Talons and then 6 breakout boards as well if you want to do the encoder extension cables. And we use those stacks for our Talons for the Talon motor controllers for a really long time. I think most people are trying to move to motors that have the control system on the motor, so they're probably not as relevant anymore. But those stacks are on our Thingiverse as well.
All right. For our part, we Velcro down our miscellaneous stuff, and that works just fine. Like our Rio and PDH and any motor controllers any motor controllers at all.
I will say that if you're Velcroing down your battery, make sure you do a good job of filing off all of the sharp edges that you're going through with your strap. Otherwise, you'll cut your strap and your battery will fall out. Our battery strap is usually a secondary restraint. So usually we're surrounding it with aluminum like you have there in the photo, and the strap is just a secondary constraint that even if you lost your strap, you'd have to really tip the robot or get hit hard for it to pop out.
Yeah, the encasing it in aluminum has worked really well for us. I think we've used it for the past 3 years. I don't think we've never had a battery fall out. We did have the Velcro cut off, like Scott said, in 2022, but the combination of that little 3D printed battery mount, I think they also sell. They might sell an off the shelf version. I'm not sure, but the combination of that to kind of hold the battery in one place so it doesn't slam against the aluminum, and then just encasing the aluminum itself just works really well. And then of course the Velcro.
And another thing does a similar thing there with the encasing aluminum, and then just like a buckle, thing that goes over the top. But the other thing that I want to mention here is the actual wire that comes off of the battery is making sure that has good routing and is secured. Because last year we had a few issues with having it too tensioned, and then we hit a bump and then it came unplugged. So make sure there's slack there. And then the kind of funny thing is that we had our the power button for I forget its name for some reason, but we had that right next to the battery, and the battery cable went over and hit the power button, turned off the robot. So make sure that your routing for that battery cable is good.
Oh yeah, and then I want to add one more thing. This year it's kind of funny because we catted the entire electronics board and then the elevator, and then we made sure the battery went in, but we didn't cat a bolt, and that bolt prevented us from putting the sliding in the battery the way that we wanted to, right? So to replace your battery, we have to do this really awkward thing of either fitting it through or like the post between the elevator and then like the back sponsor plastic, and then putting in like kind of towards yourself, or having somebody give you the battery from the front and then guiding it through. But yeah, if you're encasing it in aluminum, just really make sure that it will go in the way that you want it to.
All right. So, we touched on this earlier, but planning. So schematics, are they worth the time? And if so, what do they look like? This is an example for the redo of our electrical, and for this year. And then when you're CADing, generally, where do you put your electronics?
We didn't do schematics this year. We did it for 2022. Schematics, they're useful, but if you're CADing it already, there is kind of like defeats the purpose other than just like wire management and routing. We didn't really use it that much other than for our like engineering notebook that we did that year. So if you really wanted to do schematics, I feel you could, but I don't think they're necessarily required. And then for placing electronics, we usually keep our Roborio and our PDP in a central location, and then try to put our like our motor controllers as close as possible to where the wires will be routed either up or wherever they need to go.
Nightcrawler we did CAD out the blocks of stuff. So here's where the Roborio is going to go. Here's where the PDP is going to go. And we did do that, but we didn't draw in any wires anywhere. But what we did do really well this year, it might be the best we've ever done, is that we labeled every wire. Everything that was in the can was in the order that their IDs were. Everything had a number on it. So every motor controller had a number on it, which represented its can ID. So we labeled everything really, really well. But from a planning point of view, we just took the big blocks and put those in the CAD to make sure that they would fit on the robot.
Yeah, we've labeled our stuff really well for a long time, but we don't use numbers. We use electrical tape. So we've got a dozen different colors of electrical tape, and then every motor, every controller gets a certain 2-color pair. So your front left drive motor gets that color. So does the controller. So does the breaker. So do both ends of the wire. It makes sure that you can track things very easily from one end to the other.
Yeah, and Nomadic has also just done. I mean, we haven't done the coloring, but we just do labeling of like numbers, and that's worked well. And as for schematics, the only time we used the schematic was for an off-season electronics board, which I guess that's the thing that I should mention here. Is on a Mythic we have 3 just sort of electronics boards that aren't in a robot, that work nicely when they have their components. We sometimes take their components if we need them. But those work really well for prototyping and stuff. But as for schematics and planning and stuff, we also put the sort of blocks in CAD and just sort of we think about where wires will go, and if we need gaps in material, we make sure to cut those out. But we don't actually CAD in where the wires will go.
This might be a question more for the mentors who've been around a while than it is for the students. I remember when I first started mentoring in robotics, there seemed to be this trend that it was sort of all the rage, that all of your electronics were sort of in a suitcase type box, and you wire everything up in the box and wires came out of it that talked to your motors, and then you would figure out a place to bolt this box onto your robot. It was fully self-contained type of thing. Did anyone else experience that? Did they do that? John, as an inspector, you may have seen that more.
I've seen it a couple of times, but not very often. And it is one of the worst things you could do from an inspection standpoint. because it's often impossible to see breaker sizes, verify wire gauge inside that box. I know 2220 did it for a couple of years, and I mean, they had a heck of a time getting through inspection each time they did it before they abandoned it.
It seemed I seemed to see lots of videos on it back in the day when I was trying to learn how robots got wired and stuff. And I don't know if the idea was that you can take it from your practice chassis to your competition chassis. And I'm not sure what the philosophy behind that was, but it was never something we attempted to do. And I think we were a little confused about why you would do it.
Mm-hmm.
All right. So, connections. The slide pretty much tells it all. What does everyone do for this, and what have their experiences been with it?
We use a lot of Anderson connectors. Andersons just always seem to work. They don't really fail on us. We for like CAN and whatnot, before you want to solder it, or before we like solder it, we use lever nuts just to test it out. But we want to solder all of our CAN wires and whatnot just because it's just a more secure connection. In 2022, all of our like ferrule and lever nuts just seem to fail on us. They like fell out of their respective ports. They fell out of the fell off the wire. It could have just been like how we did it, but I think after that we just never looked back. We do use ferrules for like our PCM or like our compressor wires and whatnot. Just because they're easier to put in the actual port, because the wire gauge is so small. Or not the compressor. I think it was the
Solenoids?
pressure switch. Yeah, and solenoids, I think. Yeah.
Yeah, one thing to keep in mind when using those ferrules is make sure you're using the correct ferrule for what you're sticking it in. A lot of the Weidmuller connectors and such that we have with the required control system components do not work very well with round ferrules. So if the ferrule's round when you're sticking it in, you end up with a very small contact point, and as you're bumping around on the field, you might be dropping power. I know we've diagnosed that issue with radio brownouts over the years quite a few times. So if you're going to use those, having square ferrules or square crimped ferrules really is key to making them work well.
Well, I think we ran into trouble with ferrules the former year, and we found out what it was the ferrule tool had worn out. And that way they weren't crimped correctly. Once you have the right tools and the right ferrules, they become pretty rock solid.
I do think the ferrule shape thing may have been part of our encoder power loss issue, or the entire issue, actually. Andy can also share his thoughts on that.
I mean, our early crimpings, they weren't quite right. We just had to, re-crimp it like 3 times to get a good seal. So I don't remember exactly what was wrong with it.
Well, that was because we had the wrong the ferrule tool had actually worn out, so it couldn't crimp it tight enough for them not to come out.
I guess.
We did finally this year figured it out and got some new ones, and you cannot pull out a ferrule if it's properly installed, and it's something you can test. Once you put a ferrule on, if you can't take it off, it's going to stay on. And if you put a ferrule into one of those Wagos, they will not come out. We are trying to go away from soldering. That's where I've seen a lot of failures over the years. The other thing is, if you have solder failures, it could take a long time during a competition to try and get that redone. whereas these Wagos take like 5 seconds to make a connection.
Nightcrawler, we've done a variety of things over the years to address our wiring issues. And this past year, we didn't, to my knowledge, we didn't have any wiring failures at all. One of the things that we've done is that we make sure that anyone who's doing crimpings, whether they're using Andersons or Farrells or anything that they're crimping, they're always supervised by at least one, if not two other people. And usually one of them has to be a mentor. So anything, it's only as good as your crimp, basically, and which is everything you guys are echoing here. So that's one of the things that we've learned is that even if a veteran on the team says, "Oh, I can go do that. I know how to crimp," we always make sure there's someone there to supervise and help and make sure you've got the right amount of copper showing and you've got the crimp in the right spot. As Kevin said, we use the Wagos, but we only use them for prototyping. We did use Wagos for a previous year's robot, and we found that the Wago causes weight that swings on the wire, which causes the wire to stress, and then you end up having a break. And in previous years, we would use the old style Wago where you'd push the Wago screwdriver in, a push connector, and you'd push it in kind of like the old PDP had. And those two had a point where the wire would move, but the end would not, and that would cause stress and the copper would break. We do solder now, and we, again, solder with supervision. It can be a problem if you have a solder break, but since we started putting all of our can in order and numbering them all, we can bring up the can tool, see what number is the first number that's missing, and we can narrow down the break has to be in this wire someplace. And if we are at a competition and we would have a wire, like a can wire break, we would not attempt to resolder it. We would use a Wago as a splice so that we can get back on the field right away.
Yeah. Exactly with what Scott said. And then going back to the supervision thing, that plays into like our philosophy with the electronics. We go by like smooth or I forgot what the saying was, but it's like smooth is good and slow, very fast
Is it like
whatever, but
slow is smooth is fast.
yes, that's what it was. But yeah, because if you just do it right the first time, then you just don't need to worry about it in the first place. So yeah.
3926 for a lot of what we do use Wago tools or Wago nuts whenever we need to connect wires, just because from our perspective they're simple and fast, and we haven't had any issues with them coming out as long as we use them properly. And we kind of like trying to keep those things as simple as possible with as little room for human error.
We did see failure in the Wagos when they did not have ferrules on them.
Yeah,
so
we had
with ferrules. I have not seen a failure with a properly installed ferrule.
I think we've had one. I think the wire swinging thing likely accounts for that. Anybody's thoughts on whether tying those down right next to the lever nut would help that?
I'm sure it would, and they don't have the stress. But we use Wagos a lot for competition robots. We've soldered some can wires and stuff, but the solder creates a rigid joint, and that if that moves back and forth eventually, that's going to break. Or at least the solder we're using, it's not a soft joint. And then, like John was saying, with the ferrules, if you're putting them into like the old school CTRE power distribution panel, just because they fit in there doesn't mean that they're actually grabbing in there. Like they can pull right out if you don't have the exact right size of that ferrule going into that connector. So tinning the wires is kind of what we started doing, is just tinning them with solder to keep the stray wires from popping out, and it seems like it grabs those tinned wires a lot better than it even grabs the Wago or the ferrules. But then one other issue we had for as far as connections is this year we were with our swerve drive, we were using a Navex, We were using the one that plugs right into the reel, and if you took a hard hit, that thing would go out on us. So we switched to a NavX Micro, which is powered over USB and it plugs into the reel via USB, and that was better, but we still had issues with that too. So I don't know what kind of connection problems we were having there. We even tried hot gluing it in and still had some problems with it. So
Yeah, and that actually brings up something that I want to mention here, and that's that one of the things that Nomithic is going to try next year is hot gluing, because at Worlds we had a bunch of issues with our reel. It turns out we were missing a screw on the power connection, so we were jostling connection and losing power there. But we didn't know that for a while. And we got some help from Citrus Service, which is a little servicing competitions. But they said that they hot glue all of their like major connections to the reel. And so we did that after they mentioned it, and so far it's been working out good. And that's the thing that we're gonna want to try again.
Yeah, Nightcrawler hot glues basically everything that's not. So we hot glue like all of our USB ports, all of our like the dew point connectors that go into the reel. We hot glue all of that. Even like the Ethernet, like Ethernet ports, everything.
Yeah. I think we hot glued one point, and that was a button for setup. That went into our reel. Oh no, sorry, 2 points. One of them was the Rio to RSL. That hot glue got added between the season and MRI. It failed during the season. I don't believe it failed during MRI. So yeah, that's great. One on the button failed, but that was on the buttons end, not the hot glue's end.
For connectors, DNA uses posi locks, and we have had extremely good luck with them for inline connections for wires. The only time we've ever had problems with them is when students are doing wire checks and they pull on the wires and not like check to see that the connector is tight, but just pull on the wires. That's our only failures that we've had with those.
All right. Moving on. I didn't have slides, anything for this, but so for troubleshooting, what's everyone's process when, sure. What do you do when your arm stops working and you're almost certain it's electrical?
Yeah, once we narrow down that it is electrical, we try to figure out which connection it is. So mostly all of our wires are organized, so it's pretty easy to identify if it's broken or not. If the wire is clearly broken anyway, then of course we either use it like a connector, like the snap joint, or the what's it called? The snap lock ones on the last slide. The lever nuts. That's what they're called. Yeah, we either use those or use an Anderson. And then if it's not one of those connectors, or if it's not like a break in the actual wire itself, we check the connectors. If we see an obvious failure in them, we snip it off, put a new connector on them. Yeah. So we try not to like replace the entire wire itself, but just like reconnect the wire.
Yeah, and on Nomithic, because we use the Spark Maxes, and we've noticed those being the biggest issue in troubleshooting. And so we just check the lights, see if CAN's getting to all of them, stuff like that. Oh, and I do want to say one more thing there, because Kevin, you mentioned the lever nuts, and on Nomithic we really like those, and we mostly use those because we used some quick soldering things, which worked really well until we needed to cut a wire, and then we would just keep getting it back and back. And so that's where we also really like the lever nuts.
I know as an inspector at events, one of the biggest things I do to help teams troubleshoot is find electrical issues. When things aren't working right, something stops working, they have a short to their frame, all those sorts of things tend to be very difficult things that teams have trouble finding. The easiest way I've found to diagnose the issue is to sort of isolate your electrical system in sections. So, wherever the problem is, pick a point halfway down. Imagine sort of chopping it in half. See if one side's working correctly. If it is, then the problem's on the other side. And just sort of progressively cut it down like that. And, one of the hardest ones to find is when you have a frame short somewhere on the robot. And because it can be coming from anything. It can be coming from the CAN network. It can be coming from any of your motors. And isolating different sections to find it can be a huge time saver.
Yeah, and I think a way like Nightcrawler tries to eliminate like troubleshooting or like the time it takes to troubleshoot is inner design, just like minimizing the amount of motors we use and whatnot. So if something like for intake this year, we only use one motor for the intake. So if the intake's not working, it has to be that one motor, right? So just eliminating the points of failure.
Yeah, eliminating points of failure has been really helpful for 3926 too. We also, I think, we've kind of talked about it already, but numbering your CAN IDs really helps, so you know when something goes offline, what it is. And beyond that, I think our preferred form of troubleshooting is making things not break in the first place, but when they do, making things easily identifiable, and so you can hunt down your issue quickly.
Riley, we're getting close to 8:30. How many slides do you have left?
One.
Ah, excellent.
Okay, I do have one thing that came up last week. I hope I can ask this quickly between Riley and myself. Has anybody tried star CAN wiring as opposed to daisy chain?
Supposedly star topology. Well, actually, John, maybe you would be better at this. I've asked about this in the past, and what I found was that you may see that it works, but it's not supported in CAN. It's not supposed to work. John, do you know about star topology?
Sure. So when you look at any of our CAN buses, there's always some degree of star topology going on because every device has a little short spur that goes off into the device itself out from the wires. So you're always going to have it to some degree. Where you get into trouble is when you have incredibly long arms on your star chain. You want to really try and keep those as short as possible to avoid reflections.
Okay, I mean, looking at the documentation from NI, it basically said don't star longer than 1 foot.
Mm-hmm.
Does that make sense?
Yeah. Yep, it definitely does. And you just be aware if you're using star for the first time, you might run into problems that you're going to spend time troubleshooting to get it to work properly.
And then I guess this is Riley, were you going to say something related to star CAN cabling?
Nope.
Yeah, I just want to loop back around to what the question I asked about pneumatics earlier in the presentation.
What was the question?
I think it was how do you route pneumatic tubing so they don't disconnect on motion components or moving components?
So I think one of the biggest things we found when we're doing that is to give yourself a little slack in there and then tie down that tubing using like one of those stick-on zip tie things that was on one of those previous slides. Yeah, in the bottom right corner there, and secure it next to your piston so that the tubing can't be pulled out of the piston, even if it does get a little tug.
Yeah, Nightcrawler has it's basically the same thing, and we use it for our wiring too. So we kind of treat pneumatics as if it was a wire. So giving it a lot of slack, tying it down in like key points like by the piston, all those really help to prevent your pneumatics from going out of your piston or whatever.
Yeah,
I've also heard that you're supposed to recut that every time. Like if you unplug it and plug it back in, you're supposed to recut that tubing.
Yeah, if it's popping out on you, if it's popping out on you, you probably need to resquare the end, and because it's been compressed, you need to. But just like Jesse said, you probably need to recut that end. Might pop out once, you might be okay, but if it pops out more than once, you need to probably cut off the end and put a new end on it, or have a nice fresh end on it. I also, so when we started off the call, we wanted to save strategies to the last. So I started taking a bunch of notes on sort of general Nightcrawler strategy. I want to throw these out quick before the call's over. We always put our drivetrain first on the can so that if the can fails, at least we can still drive. We try not to put any can wires in vulnerable spots. Try to keep it below the chassis if we can. We solder our can, which we already talked about. We put our Limelight, if you're using a Limelight, I don't know how many of you experienced the Limelight freezing up on you. We started putting our Limelight on the resettable breaker on the PDP, the PD or the PDH now has one spot where you can reset it in software. And so we have a button now on our driver station that you can hit, and that'll reboot the Limelight should it go out in the middle of the match. So if you have anything like that, whether it's a Raspberry Pi Vision system or Limelight or something where you occasionally it's just hanging up or freezing or going offline, you can put that on that resettable breaker via software and then force a reboot at the start of the match or beginning of the match. We have, I don't know if anyone else is doing LEDs. There are a fair number of LEDs on the robots this year. We came up with a sort of standard LED solution for us. We use a 5-volt step-down converter that we got off of Amazon to power the lights. And then we used it's actually for a boat. It's like a cigarette lighter plug-in thing that is a USB connector to run our little microcontroller. And that way we can plug in the 5-volt converter into a normal robot battery when our students are learning how to write code. And then they can plug the Pi into their laptop for deploying code and testing. And then they take that USB cable out of their laptop and they plug it into that cigarette lighter USB plug thing. And that way it's the exact same connection every time. It's either being powered off the laptop, being powered off of this connector. So it's the exact same setup for training that it is on the robot. And that has really worked out well for us. We've tried LEDs many times in the past and ended up creating a lot of blue smoke. This new way has been better for us. Put your cans in the, wire them in the order that their IDs are. Use extension cables for encoders as a way to get your motor controller further away from things that could hurt it. Make sure all your motor controllers are mounted in a place that all of the lights are visible. That was a mistake we've made many times, many years ago. And then put strain relief on everything. Tie down all your wires and pneumatics, as we just said, in places where they could get pulled out. That was some of my sort of strategy notes that I made at the very beginning.
Well, one thing I'd add there, Scott, is it can be really useful to, it's not directly related to the wiring itself, but having side panels on your robot can protect your wiring quite a bit. So, for example, photo of our robot this here, you can see literally the only wires on the entire robot that are accessible without a piece of polycarb in the way are right on the very end of the intake there, and it's only a couple of inches going into the motors themselves. Everything else sits behind a piece of polycarb, and it makes it impossible for another robot to get in there and hit them or pull them out.
Yeah, that's a super, super great point. We cover all of our wires as much as we can with polycarb. At 10K one year, I think we ripped out just about every wire out of the Pizza Pies robot because the wires were totally exposed and hanging around. And they were on our alliance, and we ran into them with our intake running, and it came out with a rat's nest of wires. I can't even imagine how they got it all put back together by their next match, but they did.
This past season, we ran our switchable LED lights off of a Rev pneumatic controller. Their pneumatic control hub, because you can switch colors. And so if you've already got one on your robot, it's a way to power your LED lights too. And that's how we were able to switch between yellow and purple for cone or cube.
Yeah, I think having like a coprocessor for your LEDs is just so important. Instead of running it off your RoboRio, we encountered problems with running it with a RoboRio in 2022 where it just lag everything. I think Scott could correct me on that, but as far as I remember, it would just lag the entire system. It also didn't help that we had so many like subsystems to begin with, but yeah.
We've never had success with our LEDs. We tried running them off the RoboRio in 2022 and tried running them off CTRE candles last year and couldn't get it working either time.
We smoked a very expensive CTRE candle that way. So I did some research and talked to the electrical engineers mentors on our team, and we came up with this other way. We'll get it published on the website. Maybe we'll even do a session on it sometime. It worked really well. The year that Kevin was talking about with the signal light, we used the LEDs to indicate statuses. Our programmer that year, that would have been 2022, he had 27 different status light indications of what was going on in the robot, and he was frustrated that he didn't have more because we used a binary system to communicate it between the RoboRio, just using a simple DIO in and DIO out. But it saved our butt one match because we had an indicator that it had lost connectivity with the limelight. So the limelight stopped updating, and suddenly the robot started flashing red as we were putting the robot. We were just about walking off the field, and someone noticed that the robot was flashing red. And so we quick went out there. We switched places with our alliance partner, and we just did a dumb auto across the line because we had no vision for scoring. And our alliance partner was able to do a 3 or a 4-ball auto or something like that, and we just crossed the line. And had we not had that status light, we probably would not have realized that there was a problem with the robot, and so we would have not got the auto bonus that year because of it. So if you've got the time, you've got the amount of students to do it. As a previous controls mentor, it is kind of nice to have another thing for programming students to work on if you've got the capacity to throw something at them. But I will say that we struggled with LEDs and lots of blue smoke several times until we came up with this new kind of standard way to run LEDs. Riley, do you want to do anything to close us out?
I don't have anything. I've gotten through what I have.
Well, this actually, in my opinion, has been one of my favorite topics. I really, really appreciate you doing this topic tonight. I wasn't sure what to expect, but this was a great, great conversation.
Well, I'm glad it was helpful. I know it certainly will help us as we do our electrical.
I feel like electrical is one of those places where there's always room to do something better, and it's a never-ending struggle. So I think this was a great topic. I did not look it up, and I don't remember what our topic is next week. Might be PID. I don't remember. It'll be in the email. So it'll come out. What was that?
Wasn't Yoji on something?
That's in December.
That's in December. Got it.
So Yoji's doing something in December. We've got I don't even remember. It'll come out in the email. I'll get it in the email out next week. And thanks again, Riley. Really appreciate you leading this topic tonight. It was a great talk. All right.
Scouting. It's scouting, Scott.
Scouting. Somebody's doing a scouting session next week. Excellent. So we're going to talk about scouting and strategy. We talked about scouting last spring, and wow, what a fascinating talk. So I look forward to hear how people are going to approach scouting this year and if they're making any changes, because that was a lot of fun to hear all the systems people are using. I found out about 2 or 3 scouting systems I had never even heard of that look awesome. All right. Thank you, everyone. I'll see you next week.
Thank you for hosting, Riley.
That's it for this week's FRC Roundtable. Join us live all season long, every Sunday night. Visit the website at team2052.com/roundtable to sign up for weekly invites. In the meantime, keep building, keep learning, and we'll see you next week.